So my name is Nicolas Grekas. So I'm French and Greek. I work for Symfony, which is a new company that we created 2 years ago to, help the open source ecosystem and make it possible for us to do that for a living. So I'm very proud to have also sponsors on GitHub, and I do that for fun a lot because I really like hacking in our world. Before, I used to be the CTO of Blackfire, which now is a dedicated team. And this talk is also based a lot on the facts that Blackfire allowed us to actually gather in terms of performance and finding bottlenecks and basically learning how our code behaves on real world servers. So Symfony and the community in Symfony is trying hard at every single iteration to squeeze the most out of the engine and to remove code on the hot path so that it's as fast as possible and always faster. So this is a small talk from an excerpt from a tweet of Tobias, and he's comparing some Symfony versions along the years, and you see starting with Symfony 1. So what's interesting here, I think, is the number of lines of code and the memory. And basically, at every single version, we managed to remove some code from the hot path. And that's basically the most obvious trick I can give you to make things faster. It's don't run anything, right? So Symfony 5 is really fast because we managed to remove many things that were kind of mandatory before, but are just not run if you don't need it anymore. And we're continuing on this trend. So I'm not sure we can go below 0, but if we can hit a few milliseconds, we will go there. It takes it's a long journey, so it takes a lot of effort. And let's start. So the PHP engine is an amazing piece of code. I think the most amazing property of the PHP engine is that it has a really distributed leadership. It's not like one big company that is pushing it forward. It's just many passionate people, and they do their best as a community. And I think that's a really driving force for the PHP engine. So, of course, it's an old piece of code, but old and renewed and reinvented every year, every month, all the time. Just contribute if you want to make it different. We also have Symfony, so but Symfony, it's been released in 2011, and now we are at version 5. Version 5 supports PHP 7.2 minimum. Of course, it supports 7.3 and 7.4. And Symfony is one of the most successful organizations in the PHP world. There are 140 something packages, standalone packages, and they accumulate 4.4 billion downloads. So that's huge. I'm not sure that's individuals clicking on the download buttons and packages. That may be a lot of continuous integration bots and so on, but that's still a nice vanity metric to follow. So let's mix them together. Many things I'm going to tell about are mentioned by either Julien Poli or Nikita Popov. There are two people that have blog, and they have great blog articles there. So I invite you to read their blog post because, basically they already wrote about everything related to performance because they know their thing since they contributed there. So let's start. This is the PHP engine. And I think understanding the running model of the PHP engine, we all know about it, but understanding it again and revisiting how it works and what kind of implication it can have in terms of performance is what, I'd like to do that as an introduction. So we have the PHP server. We call that the FPM server usually. It can also be an Apache model. The master process manages several child processes. So those are, again, programs running in memory. So there are many of them. You can configure the number of them. And they're all run in parallel. So the master process dispatches the incoming request to an available child, right? And then each child runs one single request at a time. And then when it's done with the first, it goes with the second, and so on. So it's parallel in terms of number of childs and synchronous in terms of inside each child. There is a memory manager that clears the memory before and after each script, so that every single script in one single child process is completely separated from the other, right? That's what we know about PHP. That's pretty obvious, but this has some nice consequences. It allows us to write the code without caring about memory leaks, without caring about side effects between separate requests. And that's a difficult task and difficult challenges we just freed ourselves from solving by using PHP. So how do we make such a runtime model fast? This is one obvious solution: laziness. So to make something that has no memory between requests fast, we make it do nothing until the very last moment. That's what laziness is, right? So in PHP, the PHP engine has basically two places where laziness is implemented and leveraged for performance. The first one, I don't know if you think about that, but the first one I'm on this slide is the copy on write mechanism. So copy on write mechanism is a lazy process that tells, or that is managed by the engine, and that prevents it from duplicating an array or duplicating a string until the very last moment where you modify the string, or until you modify the array, right? So if you have a big array and if you copy this array using in a new variable, there is no memory copy that happens because of copy or write. The actual copy will happen only if and when you will alter this array. That's one low-level mechanism of PHP, and you need to have it in mind when you code and you care about performance, because this has nice consequences. I'll show you an example after. There's only one other laziness implementation in PHP, and it's the autoloader. The autoloader is very specific, a very specific technology that exists in PHP and doesn't exist much in other technologies, other runtime engine. It's a way to load code or class, as you know, but only when it's actually needed. So in a Java application, you load all classes because you compile them, they're all there, and you run that, and there is no lazy loading of classes. And so this is providing a lot of the performance benefits of PHP according to its runtime execution model. Of course, laziness is also something you're going to use and to leverage in your own application. The engine cannot know about it. So if you implement service locators, for example, service locator as a design pattern is maybe something that you should not use, but as a performance tool, it's nice because it allows implementing laziness in userland. That's one example. There are many more, of course. So the second way to actually run fast when you have a runtime execution model where every single request starts with empty memory is to use a cache. So that's the second and actually the only other way to maximize the performance of a run on forget runtime. So laziness first, and caching. So caching is about not doing twice something we did before, and we're using the result of the previous computation the next times when it's just fine because the source data didn't change, right? So caching at the PHP engine level, there are several places where caching is used at the engine level. I'm not going to talk much about caching at the application level because you know about that, and it's your job to decide when and how you're going to manage the cache. I'm going to talk a bit more about the caching that happens at the engine level. So at the engine level, caching needs, because to cache something, we need to put the cached value somewhere. And there are two places, two shared kind of reusable memory in PHP. One is what we mention most of the time, which is called the shared memory. So every operating system manages some shared memory that several processes, all child processes, can access to and read values there. So that's, we're going to, and PHP is going to leverage the shared memory. There's another memory, which is the child process memory. So a single child is a process, and this process has a memory. So basically this memory can be also reused between requests. So PHP has this memory manager that prevents actually reusing the memory process from one script to another, except for persistent connections. So if you don't know what a persistent connection is in PHP, or if it's an obscure thing, a persistent connection is a connection handler that stays in the child process. It's not put in shared memory, it stays in the process memory, and it's one of the only few things that is shared between a request for a single child. Okay, what does PHP cache? So PHP has basically, I think, three main caches. One is the real path cache. So you can control the size of this one, and it allows skipping some I/O, some file system I/O. There is a cache for the regular expressions, because when you type them as a string, they need to be compiled to be fast. So there is an internal shared cache for the regular expressions. And there is, of course, this cache we all know about, which is OP cache. Let's talk a bit about it. So OP cache. OP cache is a PHP extension. It used to be a closed source technology, and now it's open source, and it's native since PHP 5.5. And so what OP cache does is that it actually caches steps that don't need to be run all the time, so compilation, right? So we have the source code. The source code is lexed and parsed to build an abstract syntax tree, and then the abstract syntax tree is compiled and turned into a list of instructions, which we call the opcodes. And all these steps, they depend only on the source code. So if the source code doesn't change, we can cache them all. And of course, after that, we can execute the script and run fast. So all this in red, all the result of these steps can be put in shared memory, and then executing basically borrows from shared memory to run the script. So compilation, the compilation, so the abstract syntax tree is turned into opcodes, and there are some compile time optimization that happens there. So I have two on screen. One is compile time evaluation. So if there are static values like numbers and static strings that are computed, like addition, subtraction, multiplication, concatenation, and so on, the engine will pre-evaluate this for you during the compilation step. PHP also will do dead code elimination, which means it will spot conditions that are false at compilation time, and it will just remove the opcodes that are inside the if, because they are just useless code, dead code. In practice, you don't see this kind of code, but I'll show you when you can actually, and when it's useful just after. There are a few other things that can be put in shared memory. There are strings. All the static strings that are found in your source code, they can be put in shared memory, so that then the program can, your script can only manipulate them through a pointer to the shared memory, instead of having to deal with the buffer, the full string, maybe it's 1 megabyte, I don't know. Instead of copying 1 megabyte of data to deal with it, just having a pointer to the big string that is in shared memory works. And it works well, of course, because of the copy on write mechanism. If you are not going to modify this string, it is going to stay in shared memory. As soon as you modify a string, of course, copy on write will generate or trigger the copying of the full string. The same happens for arrays. In practice, dead code elimination works with PHP constant. So if false, you never write that in the code. But if the PHP SAPI is the CLI, This is the kind of code that we can find in our source. Another one is if the version of PHP, so if the PHP underscore version underscore ID constant is higher than 7.3, then do this code, otherwise do this code. These kind of checks are free in PHP. They don't cost anything at runtime because the compilation step resolved them beforehand. And this is when dead code elimination can be very useful to generate the fastest possible list of opcodes. Another one, there are some functions that PHP is able to compile. So count is one of them. I'll show you a few more after. And this needs PHP to be able to resolve the count name, the name of the function, to resolve this name at compilation time, which means it needs the name to be fully qualified. Usually you can do that using a backslash before the name in PHP, or you can use function count at the beginning of your files to say the same, basically. So an example is this one. When you use isArray in a namespace, because you don't know if isArray is the isArray function in the app namespace or in the root namespace, PHP generates a list of opcodes, which we see here, which is init ns fcall by name. And then there is do fcall. And basically, those are slower opcodes than the other ones on the right side of the screen. So now if we fully qualify the isArray function, then PHP at compile time knows that this is an array check. And so it generates two opcodes, which are much faster than the previous ones. And you can see it just does a type check. So the list of functions that PHP is able to resolve at compile time is finished. It's written hard-coded in the source code of PHP. It's not going to grow much because growing that list makes the engine slower. So this list is almost finished now. So I put it there. There are some pointers and some links if you want to figure out more of the source of that. So immediately, okay, one example of a practical performance improvement related to this is a recent example. This is an isNull check in some SCSS PHP parser. And this is a tweet from Stuff, which is a community member in Symfony. And just by adding this backslash in front of isNull, he's turning a function call into an optimized opcode. And this removes 23% of the runtime of his example there. So that's a big win for one single character change, right? My advice now is these benefits only to a few limited functions, right? So the backslash here makes isNull faster because there is an opcode corresponding to isNull, right? All the other functions that are not that don't have any opcode corresponding to them, they don't benefit from the backslash from a performance point of view. So my advice here is don't jump to an easy conclusion and add backslash or use function for every single function. You will just add visual depth in your code, and you will not get any performance at all from that. So there is a PHP CS fixer rule that you can activate, and we actually use it. It ensures that the backslash is added only on the functions that actually benefit from it, and that it's not added to the other ones, so that you don't have brainfuck source code with full of backslashes everywhere, or lines of use function at the top of these files for just no practical reason. Okay, another topic. So PHP is slow at compiling. Slow at compiling is all these steps before the cache is warm. All these steps, they take time. So we figured out this by looking at a compiled container at the time. So a Symfony container used to be one single big generated PHP class that contained the source code to create any service in Symfony application. And we managed to actually split each service into a dedicated file and to have the main container just reference those files, right? So instead of one big class with many methods, we have one small class with many files that contain each the service definition in PHP code. When we did so, someone reported a huge performance improvement in their setup. So from 130 milliseconds to 15 milliseconds. That's huge, right? How is that possible? So you can see also on the memory side, almost 17 megabytes and less than 1 megabyte after the optimization. So how is that possible? Was Symfony that slow because of this big container? Of course, no. This tweet and this benchmark in comparison is from a command line application. But that's a real-world command line application. So because on the command line there is no shared memory at all, everything we're talking about, caching, opcode caches and so on, they are just useless, right? So on the web, you won't not see this kind of performance improvement, of course. But on the command line, if you have a command line that runs in a loop, and some people have some of them, then you will, this optimization provided some really cool improvement for them. So on the web, there is still a benefit from doing this. You might say, oh, this is in shared memory, so one big single content compiler is not going to be either slower or faster than several files, right? You could even say, oh, it's going to be slower to split in several files because several files mean several require statements, one per file. So doing many requires where there were none before might be slower. So what is the fastest path? Big container or separated files per container? So I run the benchmark, of course, for you. And the benchmark is this one. So performance improved. So the time lowered by 1%, and memory also diminished by 20%. The I/O in the middle, the 70%, we don't care at all because it's 70% of something that is really, really small. So I'm not going to mention that more. But the memory is nice. And why is it faster to not load this big container? Why does it take less memory? And the reason is that until PHP 7.3, the opcodes, the compiled opcodes, had to be copied from shared memory to request memory all the time. That's something I learned at the time, something maybe you didn't think about before, but when we say the opcodes are in shared memory, actually before 7.4, they are transferred all the time from shared memory to local process memory. So if we have one big container, there is maybe 2 megabytes of opcodes that are copied from there to there. This is really, really fast. It still takes time, right? And we don't see the effect of require at all. So yeah, PHP 7.4 is now able to keep and to reference the opcodes directly from shared memory, so it removes these copies. Let's get back to intern string and immutable arrays. Those stay in shared memory. I mentioned that before. There is a buffer, a PHP ini setting that you can configure to give the size of these caches. In terms of code, this is an example from Composer that benefits from intern strings and shared array, static arrays. So if you see the top of the screen is the Composer class map using a variable to reference the vendor directory. And the bottom of the screen is the same value, except that now instead of using a variable, we're using the magic dir constant, and some relative path traversal. And the bottom array fits in shared memory. The top array does not fit in shared memory. And if we have big composer class maps for autoloading, this makes a difference. So I put some references and blog posts at the bottom of the screen if you want to get deeper into that. But basically, by generating static arrays, you save memory copies, and this makes a difference. So that's something you can do now in your code, taking care of that to maximize the use of shared memory. We gained almost 10% on loading the composer class map by just doing that. And as you can see, 32% of memory. I don't have the raw numbers than the blog post, but that's significant for the use case. So copy and write, I mentioned that at the beginning, but copy and write is something that happens when an array is modified. So if you see this example here, we have the A variable. Let's say it's static. As soon as you change anything in the array, it's going to generate a copy of the array. And so it will take time to copy things, and it will take memory to hold the copied array. And this happens for strings also. So first line A equals ABC, B equals A, there's nothing that happens except a pointer. And then as soon as we modify B, then ABC is duplicated, and one of the duplicates, the B side, gets concatenated, gets with this GHA appended. So that's maybe something you might want to care about in some performance sensitive algorithm, to not trigger copy and write maybe when you don't need to. Yeah. So an example of copy and write and code that is written to benefit from copy and write, and I would say the opposite, to not break or trigger copy and write. So this is the two examples, one in Symfony, one in Composer. The first example is abstract recursive path. As you can see in the for each array, it's kind of strange. We have this array, we process the array, for each array has key value. We process the value with some function. We don't care about what it does. It's going to transform the value and to return a potentially modified value. And the processed value, we compare it to the original value. We say if the values are different, then put the processed value in the array, right? If we just remove the if, logically, the logic there, the code there does exactly the same. We don't need the if to get the expected result. The if is useless from a logical point of view, right? But actually what it does is that it checks that values are actually different before triggering copy and write. Just affecting even the same value to a key does trigger copy and write, because the PHP engine cannot know on the copy and write side if the values are the same. So on the class loader, there is this class map internally, and the class map used to be one single PHP array to hold both classes that exist and classes that do not exist. So when there's a class that is loaded but it's missing, Composer is caching the miss somewhere, and it used to cache the miss in the same class map where it holds the existing classes. And by doing so, it was breaking copy and write. So now we have two arrays internally. We have one class map, which is immutable. We never modify it, and it's statically declared, I showed you before. And we have the second array, which is missing classes. And this one holds only the missing classes. And yeah, we compute it at runtime. So what else can be slow in PHP? So we already screened things that are slow or can be faster if you're careful enough. One thing that can be slow is the autoloader. So if we are able to bypass the autoloader, then it's going to be faster, right? It's okay, not that obvious and not that mechanical. In this example, I'm showing a special parameter in Symfony that we added that is removing some debugging autoloader for service classes. So the debugging autoloader is something that wraps the composer autoloader in Symfony and ensures that, let's say, the case of the characters matches in the file system and in the class declaration. It does basically some reflection sanity checks on top of regular autoloading. It runs only on the debugging stack, of course, and it takes time, of course, also. There are many classes that don't need these checks, and we managed to figure out how to not run this autoloader for service classes. There is a parameter, now it's enabled by default, and what we did in the code was is actually generating raw require statements in the dumped generated Symfony container, because we know the class, we know the file, so we can just, instead of relying on autoloading, when a service is used, we generate a require and we bypass the autoloading stack. And this gives, in development, a very big performance improvement, of course, because of what I just told you. In production, also, we measured something like 2% of improvement. That's nice. But preloading is going to give us much more on this specific topic. I'm going to tell you just after. The garbage collector is something that can take time. Takes time when you have a lot of objects in PHP. So yeah, the memory manager. So this is something that has been improved in PHP 7.3. So before 7.3, the garbage collector used to be triggered whenever the number of objects went above 10K objects. And now this 10K is increased. If you pass it one time, it's going to go to 20K and 20K, 30K, and so on, so that it adapts automatically and it doesn't trigger garbage collection too often. Okay, some quick tips. So that's the tips and tricks section. If you are using the coalesce operator, the double interrogation mark, it's much faster than doing the ternary isSet equivalent. You can bench that, it's faster. If you use constant or string interpolation, it's apparently faster. I'm saying apparently because in practice, this is a tip I'm not using myself because I never measured in practice when it made a difference. But okay, there are some generated opcodes that are different and that apparently are faster when using the version on the left side. Maybe, you'll tell me. There are packed arrays. So packed arrays are arrays where the keys are numbers and they are only incrementing numbers. There can be holes between numbers, but they must be incrementing numbers. And if you have this kind of array, PHP will use a packed structure, which is going to use less memory and so require a few less CPU cycles to manage. So if you can optimize your structure for packed array, you might see some difference in some depending on the use case. Another tip, another thing we did in Symfony, when you have a default value on the signature of a method, so this example, you have this invalid behavior argument. By putting a reference to a constant, we had the code slower than needed. So what we did at the time is that we inlined the value and we put a comment to say, hey, this is actually this constant, but we are not using the constant because it's slow. So, okay, maybe it doesn't matter, and I think it doesn't matter in your application. It doesn't matter also if you are running PHP 7.3, because we reported that to PHP internal and they managed to make it, to reclaim the loss. That's the kind of trick that micro benchmark allowed us to spot. And that's why that's how we learn about that. A few more. So copy and write. If you do casting with the string and the array cast, they do not, if you use them, they do not trigger copy and write. In PHP 5, they used to trigger copy and write. That's not the case anymore. If you are using a switch statement, the switch statement is now very optimized. So it's using a hash map to jump between the case statements. So you can use it. It's really fast. Just be careful with the type, of course, of the case of the value that is switched on. Try to use only strings or only integers without having to trigger type juggling. If there is a callable, like PHP callables using an array where we put, let's say, this and the method as a second key in the array, using that correctly works, but is slower than first transforming this array into a closure. So closure from callable generates a closure, of course, from the callable, and the closure is faster to use than calling this and method as an array. So if you have this thing in a loop, call first closure from callable and put the closure call in the loop, and you'll gain some performance. At the beginning, I mentioned the real path cache. So the real path cache actually a fstats cache. So it caches all the fstat system calls, and isFile is reusing this cache. So isFile is faster than fileExist because fileExist does not use this cache. That's something I learned very recently, and we made some pull requests to Symfony to actually replace many fileExist in the source code by isFile or isdir, of course, if we're checking for a directory. So that's an easy win. So you can do it. You'll see some benefits. Some pro tip now. If you make a property public, or if you make a method public, it will be faster. Accessing them will be faster. You can try. You can give it a try. If you if you don't use protected or private properties or methods, but only public ones, your code is going to be faster. I'm not saying this is what you should do. I'm giving you this performance fact. Do what you want with that. That's what I'm adding at internal only. The same happens for type hints. Until now, we don't have just-in-time compilation. We don't have advanced optimization that benefit from type hints right now. If you remove all type hints from your code, I suppose your code is type hint safe, right? So you don't need the type hints. So I'm kidding. But if you remove them, again, PHP engine is going to run your code faster because it will remove the runtime checks related to type hints. So again, that's a fact. That's not a recommendation, but we need to have the facts first to decide, right? Okay, PHP 7.4 provided us with preloading. I'm not going to spend, or I could do a full talk on preloading. So let's just a few things, critical things about preloading. The first is that preloading is about removing everything related to loading classes. So preloading is replacing the autoloader, so it's replacing the autoloader, including the resolution of class inheritance. Variance, covariance, the signature, compatibility of every inherited method, and so on. So this takes time, and this happens all the time for every single request. This is something that is not cached before 7.4 and without preloading. Preloading also removes all freshness checks. So preloading loads the code and considers it immutable. So it's not going to check anymore. Preloading is sensitive to over-preloading, which means you preloaded too many classes, and to under-preloading, which means you preloaded not enough classes. So there is an optimum, and the optimum is not to load everything, and of course the optimum is not to preload nothing. So there is an optimum to find between preloading everything and preloading, and this is the challenge in preloading, which is being able to identify which classes should be preloaded and which classes should not be preloaded. And preloading has some constraints. The two critical, more important is first you need to write a preloading script to decide which classes you're going to preload. And then preloading works only or allows only one single version of an application per FPM server. So if you want to run 2 applications in the same FPM server, you cannot use preloading, right? Okay, so preloading, there are 2 strategies to do preloading. One is to use include or require and autoloading, and another one is to use a pcache compile file. Use include plus autoloading, that's the most effective way. In Symfony, preloading generates, in Symfony, when we compile the container, I talked a lot about that today. When we compile the container, we generate a preload.php file out of the box by looking at the service definitions and by triggering cache warmers, and they will list all the classes that are useful for the application, and it's a pretty optimized list of classes to preload, so there's actually nothing to do to benefit from preloading in Symfony. It works out of the box. You just need one ini setting, and you'll get a nice performance benefit. So on the Hello World, I measured something like 75% performance boost. That's huge. That's because the Hello World does nothing else than loading the framework, right? And so autoloading was a significant part, or is a significant part of running a Hello World in Symfony. For typical application, my experience is that between 15 to 20% of the time is spent autoloading code, and by having an optimized preloading script, you can reclaim this amount of performance. Tricky example here, and that's my last slide. This one is about some maybe surprising patch that you might want to do in your code to maximize the benefit of preloading. When we preload a class, when we require this session class, automatically PHP will trigger autoloading for all its dependents, right? The parent class, the interfaces. PHP will trigger autoloading for that, and preloading will be able to discover all the related classes when you load one main class. What PHP and Reflection cannot give us is the list of classes that are used inside the class. If there is a new attribute bag, like at the bottom of the screen, there is no way to know about it using only Reflection. And so preloading would fail at preloading the attribute bag unless you give it a hint. And this is the top of the screen. These are 3 hints telling when this class session is loaded, load also these 3 classes. And this will boost preloading. You will get maximum performance by hinting the engine with these lines. Yeah, okay. Thank you very much. I hope you enjoyed the talk. I hope you learned a few tricks. PHP 7 is awesome. The work there made us having a really top-notch runtime engine, a very special and unique execution model that has, it's the driving force of PHP. The source code, the PHP source code is in C. Writing it, I'm not able to do it. Reading it, okay, I think there are some ideas that we can get from the PHP engine, so don't be afraid of opening the source code. We are talking about performance, and my last 2 points are about measuring things. Performance improvement don't make sense without ensuring that things are running in tight loops, and there are some actual numbers that prove that a performance or that some patch has some performance benefit. And I'm going to stop on that. Thank you for listening.
Wonderful. Thanks so much, Nicolas. I feel like I can write much faster PHP now with all the advice. We do have a few questions. I believe we're actually going to do 1 or 2 before the break. Is that correct?
Yeah, works for me.
All right. I think we've got, we're going to bring in 1 or 2 questions. As we're waiting for those questions. Yeah, go ahead. Sorry, I'm hearing two voices in my microphone.
Hi, Nicolas.
Hi.
Nice to see you. So I have a question from Andrei. He would like to ask whether using functions as an import is the same as adding a backslash. Is it optimized
Yes.
in the same way?
It's exactly the same. What matters is having a fully qualified identifier, and both provide a fully qualified identifier. So it's exactly the same.
Okay. So then I have another question. How do you personally keep the balance between an optimized code and a beautiful code? Because some of the Symfony classes are a bit hard to read because they are more optimal than beautiful. How do you keep that balance when you're writing components?
We look at the hot path. We look at which part of the code is running in tight loops. There are places, I have one in mind, which is not the kind of code you're going to write yourself, but the var dumper component. The var dumper component is going to recursively look at potentially big values, big array structures. And this piece of code is maybe not that completely designed, so that's readable, but it matters that it's fast. It must be fast because you don't want the debugging tool to be slow because, okay, we added design pattern there. You want dump to actually dump now. So that's how we made the balance, and we decide. Of course, it's a personal judgment all the time.
Okay. Because I very often see that you write in the top message of every pull request you make that it's an optimal balance between the usability and the optimization. So I would like also to ask about the typed properties which we have in 7.4. Do they optimize our code, speed it up, or they don't?
In terms of performance right now, as far as I know, they make the engine slower because they add runtime checks, but not to an amount that matters. It's a technical thing. When I'm saying it's slower, I'm sure you cannot measure it, and I'm sure the benefit of using type variable is much higher than not using them. This is the case where I would say design matters more than performance. Maybe in the future, with just-in-time compilation or more advanced version of just-in-time compilation, maybe in the future, having type properties will help the engine do some optimizations by skipping type checks. I hope we'll reach the point where this will be true. So right now we're not there, so yeah.
Okay. So another question from the audience, how to choose the real path cache size? So this is, I suppose, a PHP config.
Yeah. There is no magic trick. Run the application, look at how much of it is consumed, and increase when it's full. So Blackfire has a tool to that. To do that, there is a reporting recommendation system, so you can use Blackfire for that. You can also use, of course, your own script. But basically, the only way is to see if it's full and to raise the ini setting and to iterate based on that. But I have no better answer.
Okay.
Awesome. Thank you so much, Nicolas, for that excellent talk.